Okay, we are back for day 2 of this build of a TR uSDX. Yesterday we did most of this board, the TR uSDX. We got our buttons, our rotary encoder, our OLED, a couple three headphone ports. We also did the mod for the OLED. We also have our header and our ICSP header. Hopefully this camera view will be a lot better for seeing what we're doing. I was able to look overnight, and gotta look here. The maker of this, Mr. Manuel, I believe that's his name, he is from Germany, if I'm not mistaken. He said to figure out which post of these is grounded to the frame. So what we'll do is we'll turn this around so that you can see this. I like old analog meters. I just feel like they give me a better reading. You do you. There is a plus. I don't know if you can see it on there. There's a little tiny plus sign there, but we're going to double check it. So that one is grounded to the frame, and well, that's actually a higher reading. So that needle went all the way over here on this one. On that one, it's a little bit lower. So this is our ground lead right there. So ground lead is confirmed. I don't know that you can see it. I can barely see it in this lighting, but this pin right here actually has 3 little connections to the ground plane. So that's going to be our ground. So I'm going to turn this and make sure I have it right. Bear with me here. I'm going to drop that in. Right like so. And let's turn on our soldering iron for today. Again, I've got it on about 400 degrees Celsius. Again, we are dealing with metric people. Even though I'm in the United States and we use the SAE system, we are going to be using metric throughout this. So yesterday we talked about kind of the history of ham radio. Today we're going to talk about my history with ham radio. So growing up, my father had CB, Citizens Band, in his truck a lot. I remember this was early 90s, 95-ish, or mid-90s I should say. We had a PC. We had a Windows 95 computer. And he was coming home one day, and I could actually hear him over the CB on the computer speakers. So we were picking that up. I remember that happening, and I thought that was so cool. And I wanted to learn about it. The other thing that kind of led me to ham radio is my father went out, because he was doing so much with CB and he was doing storm spotting and stuff. A friend of his, teacher of my siblings actually, my sibling's 6th grade teacher, was a ham radio guy. There we go. Not the best solders in the world, but they will do. He was a ham radio guy, and so my dad ended up getting convinced, hey, why don't you get your ham radio license? So that's what he did. He went out, he got it. My brother was interested as well. So both him and my brother went out and got their ham radio licenses. I've always thought that was kind of neat. I always wanted mine. It took me a number of years to get up the courage to go ahead and get mine. And so last year, or not last year, back in 2019, I said this yesterday, I studied for it for about a week straight, took a week off, went ahead and took it and aced it. So I was cramming the morning of. Alright, on this one I do see, so they already have red and black on this speaker. I don't think that there is a positive and negative on the speaker. Let me go to the paperwork about the speaker. Hey, there is a positive and negative. So if we look at that, the positive is on that side. So as I look at the board, and I gotta look at it in the right light, it looks like this terminal is to the ground plane, and we can test that. So let's bring our meter back on over, and we are going to touch right there and right there, and those are connected. That to that is not connected. That is not. That is. So we know where ground is, and this is magnetic, so it is sticking to my all metal table. This is a steel table. My brother, the ham radio operator, has it, or made this. Alright, so we are going to kind of go like that. So we'll hold these where they are, and we'll flip, and I have gotten fairly good at dipping for some solder and going to the terminal. If you want to learn more about soldering, I'll tell you, a great place to learn, or a great way to learn, is by doing. Find your local makerspace and go ask and see if they do anything about soldering. A lot of them do, and you can learn a lot at one of those. That's actually where we're at right here. We are in the McPherson County Makerspace. I'm actually one of the admins here, and we were opening this place about the time I got my ham license. So I want to thank like Ham Radio Crash Course and places like that. I watch their videos on YouTube. I still do from time to time. They are a great resource, a lot more concise than I am here in my little photo studio in the makerspace. So they have a lot more information at their fingertips than I have. I mean, I could have it. Computer's not that far away, but alright, so right there is our speaker. We want to be careful with that because there is a membrane there. We've got the positive and negative all done. Yesterday I started a 3D print for the case. Again, I'm out of makerspace. Might as well use what I've got here. But it did not turn out right, so I'm going to have to 3D print that again today. So as soon as we get done with this, I'm going to be going over there and starting a new print. Ooh, that was bad. Again, be careful of that speaker. What I want to do is I want to clip these. I got the wrong clippers today. Grabbed the wrong ones off the shelf. Yeah, I'm going to have to do that some other time with a different set of clippers. I need some that can nip at the end, not these that cut down in there. Alright, well, we are going to set this board aside because we are pretty much done with it. The only thing we got to do is clip those. And I think that's about it. That's all we've got. Give you a good look at this board and the back. Alright, so we move on to the more fun board. The low RF band board. Alright. So this one, I'm going to have to do some reading either online. Yeah, I'm going to have to read about this online, some of it at least. Yeah. Bear with me. I was thinking that this board had information on it on how many turns on what toroid, which one of these, it had. So while I'm looking that up, I'm going to give you a good shot of that board, and I'll give you a good shot at this board at the same time. So ham radio. Other thing that I'm surprised that we have not seen more of. Preppers. I have not seen as many preppers as I thought I would see getting their ham radio license. By the way, guys, you guys that have your that went out and bought little Baofeng radios, thinking, all right, well, if the worst should come to pass, I want to have a little Baofeng ham radio that I can use, but didn't get their license. And you know what? That's fine. You can have your radio in case of an emergency and never use it. That is fine. That is legal. You can listen to it all you want. But what I do caution people about is, if that's what you're doing, if your goal is to have it for an emergency situation and you don't practice using it, and if you practice using it without a license, that's illegal. But if you don't practice it, if you go the legit route and you don't practice, how do you know that you're going to have the knowledge, the ability to do what needs to be done when it comes time? I mean, that's part of why I'm building this radio. I want to be able to make emergency communications if need be. And the way I'm going to do that is having radios around me. And I'm going to have radios around me by legal, well, and I'm going to have radios around me, but I'm going to be able to know how to use these radios because I've practiced. That is one of the biggest things, is practicing making contacts. You don't want to be the guy that hops on and is fumbling around going, all right, how do I do this? How do I talk to this person or that person or whatever? You don't want to be that guy. I don't want to be that guy. Alright, so I've got a schematic pulled up here. This is on dl2man.de. Comes with it's the guy that made this board possible. And what it's got here, oh, let me turn it that way. Okay, what it's got here is, here's where I'm looking. This is one of the manuals on it. And I'm looking at this 20-meter circuit. What I'm really looking at is L11. This is a 10T, which I believe this is one of those 10T, and it's 10 turns on a T37. This is the T37, and I'm going to do 10 turns of this wire for L11. I believe that's how that works. If I am wrong, I apologize. I'm not trying to lead people astray. I'm trying to build my radio. So, but yeah, that's how I got into it. So with preppers, I'm surprised that we don't see more preppers coming to the hobby and learning how to use these things. One of the big things that I'm still mind equals blown with is antennas, antenna theory, and how little, without taking a master's course on antenna theory, how little there really is about how antennas work. I'm an electrical guy. For those of you that have followed my channel, not many of you, because I don't have a big following, because I don't deserve a big following. But for those of you that do follow my channel, you guys may know that I was working on DCC in a box, and I do have an update for that. I need to post it. I've just been super busy. Alright, T37. And guess what? I could have looked at this. This actually has all of that mapped out for me. But this is, the schematic helps me too. Alright. So, yeah, for those of you that have been following, I do ham radio stuff, or I do model train stuff. I do ham radio and model trains, and I am a student of all kinds of things, too. So one of the things that I study is, and play with, is model trains. And model trains are very interesting, and you can learn a lot, and there's a lot of overlap between ham radio and model trains. For instance, soldering. I do a lot of soldering. I end up soldering a lot more heavy gauge stuff with model trains, but there's soldering in both. And that's where I learned to solder, was in model trains, and I've carried it over into ham radio. So if you guys are looking for another hobby to dump loads and loads of money into, well, that may be another one for you. Alright, 1, 2. And what I'm counting here is, if you look, how many turns do I have on the inside of this? So I got 1, 2, 3, 4, 5, 6, 7, and so I need 3 more. 5, 6, 7. So yeah. Yeah, I learned a lot in model trains of soldering and electrical and stuff like that. And a lot of circuit design with that. A lot of you don't cross your positive and your negative in DC. Growing up, my mother bought a different house. We moved, and we ended up having to. It was a fixer-upper, and we kids lent a hand. And my old boss lent a hand, and we rebuilt that house basically from the ground up. Basically. So yeah, I mean, I learned a lot about electrical that way. And where I was going with that is I understand electrical circuits pretty well. We did our own electrical in the house. I've done a lot of electrical in model trains. I actually went to college and took some classes on stuff like this, on circuit design and stuff like this. Took a number of classes on it. And when I started researching antennas and how antennas work and the theory behind it, I was shocked at how little information there is, and what information there is out there just does not make sense in my mind based upon my history with electronics and electrical and everything. It took me a while to get my head around that, to get to grips with what's going on there. So, alright, what I'm doing is I'm trying to take the coating off there so that when I put it, wrong board, when I put it on this board, and I am looking for L11. There's L22, L11. So I see L11 right here, and I look at my thing right here, L11 gets a T37 with 10 wraps, and there are 2 of those. So L11, dropping my leads in. I'm just going to give it a little twist on the back, and that'll hold that there for now. Notice I got all of those wraps separated fairly equally. That's what, again, the designer, DL2 MAN, says to do. And I need to apologize and say, you know, there is another designer with this. He was, DL2 MAN was not the sole contributor for this. If you look at his website, he is giving credit to Papa Echo 1 November Zulu. I'm sorry, I don't know your name. PE1 November Zulu. But you get credit as well for this design. And hopefully, here in a little while, I can say you guys did a phenomenal job designing this once I have this thing up and going. You know what I'm not doing a phenomenal job is my wire management here. This is becoming a rat's nest. All right, there we go. And let's start wrapping another one. So what do you guys think about this format of me working on something and talking about it? Is this better than my talking head videos? I kind of think it is, personally, but I want to hear it from you guys. Is this better? You guys like this better? I can also give, based upon what I was saying earlier, I have a lot of experience with soldering. I know it doesn't look like it here. I'm actually operating without flux right now. So my flux is actually at work and I don't have it with me. So I'm doing all this soldering without flux. But I can do videos about soldering if you guys are interested. Whatever else you're interested in. I mean, I can talk about most anything. I can talk about finances. I can talk about relationship advice. I can talk about, well, sky's the limit. I can tell you my theory of a lot of things. I've got some ideas on some free energy devices, and I want to make a distinction. All right, 1, 2, 3, 4, 5, 6, 7, 8. Need 2 more. I want to make a distinction between free energy, as in perpetual motion, and free energy, as in you get something for nothing. All right. You get energy without having to pay the government or your local electrical supplier for it. I want to make a distinction there, okay? As I see it, the only free energy devices that can exist in nature, in our universe, are like, well, you know what? Solar panels are a free energy device. Before I cut this, I want to count one more time. You guys can count with me here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 there. Solar panels are a free energy device, technically, as I see it. And they are some of the only free energy devices that can exist in our universe. All right? So let's go on that topic a little bit, I guess. I'm kind of freelancing here. Free energy devices. Real quick, we're going to look here. We did our 10 turn on the T37, L11 and L32. So looking on the board here, we did L11, which is notated right there. And here is T32, or sorry, L32, which is L32. So we will drop this one in. So yeah, free energy devices. Why do I say they and I forgot to strip. Why do I say that free energy devices, the only free energy devices that can exist in our universe is stuff like solar? By the way, wind is a free energy device, is one of the only free energy devices that can actually exist in our universe. For that matter, free energy device, if you have your own gas or oil well, and you can pump it, if you have the means of pumping it without paying somebody, and you can burn it, you can refine it and burn it yourself. Let's say that you get natural gas directly out of the ground from your property. That is a free energy device. That is a free energy location. Do I recommend it? Do I think that that is the future? No, I do not. All right. L32. L32. So we're going to put that in there. There's wind, there's solar, there's actually wave power. You can get energy from wave power. There's a number of other sources that you can get power from that don't break the laws of physics. Why do I say that it breaks the laws of physics? Well, physics tells us why. All right, now we're going to do on a T37, one of these red ones, we're going to do 7 turns, and we're going to make 2 of these. Why do I say that free energy devices have to be like wind or solar or something like that? In the theories of energy and mass and energy have to be conserved. I don't know all the theorem terms and everything, but I do know that you can't make energy out of nothing. All right? There has not been any device made on Earth or in space, in our universe, that gets energy out of nothing that we understand, that we fully understand. There's a lot that we don't fully understand, but what I'm talking about is everything that we use for power here on Earth. If we have knowledge of, hey, this is how a motor works. The gasoline gets burnt. 1, 2, 3, 4, 5, 6, 7. Hey, I'm already done with that one. Your gasoline gets burnt in your engine, and internal combustion happens, and because of internal combustion, we can utilize that. And I'm going to count again. 1, 2, 3, 4, 5, 6, 7. All right. And because of internal combustion, we can propel our cars, and we can use that energy to go. The energy came from somewhere. Where did it come from? It came from the gasoline. Where did it go to? It got dissipated in locomotion. It got dissipated in heat. It got dissipated in kinetic energy. Potential energy got converted to mechanical energy, to locomotion. And the locomotion of all sorts on Earth has friction, has a wind that is slowing you down, has a lot of things. Gravity plays a factor. All right, this one is going into L12. L12 looks like it's right there. So that energy gets dissipated in a lot of different ways. So anything like hydroelectric, stuff like that, energy is coming from the water upstream, and the water is going downstream. It lost potential energy as the water dropped. Okay, looks like we only had one of those to do. Next one is a 12 turn. We're going to go to a 12 turn. It looks like L21 and L42. I want to turn this the right way to make sure that I read that right. Yes, I did. We're going to do a 12 turn. So, conservation of energy and matter. Alright? We can take matter and we can get energy out of it. What do I mean? Gasoline. Let's talk about gasoline for a minute. Gasoline has energy in it. That energy is combined with carbon. It's a hydrocarbon. So that energy is combined with carbon, and the carbon locks it in. What happens when you burn it? When you burn it, you oxidize the carbon, and it releases energy. That's what burning is. Burning is just oxidizing a chemical. It's a chemical reaction of oxidizing whatever you have. So you oxidize it, you give it oxygen in I say in a controlled way. The control is the fire. Sometimes the fire gets out of control, but that is controlling how it gets oxygen. 1, 2, 3, 4, 5, 6, 7, 8. So that controls how it gets oxygen. You are oxidizing that matter, and everything that leaves, so all the smoke, all of the energy, all of the soot and ash afterwards, if you add all of that up, all right, and you say, well, energy doesn't have weight, and it can, depending upon, it's depending upon how it's released. It's not really weight of it, but it's releasing other things, and that's releasing the energy. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We got one more to go. It's releasing that energy. So when you release that energy, when you release those chemicals, the ash and soot and the carbon dioxide, we hope it's CO2. We hope it's not carbon monoxide, because that's bad. That's what happens when it doesn't have enough oxygen and you're burning it. Did you know that? It's carbon monoxide, like carbon monoxide poisoning, the scary stuff that makes you sick, and if you don't know about it, it makes you go to bed and you won't wake up the next morning because you suffocated and you're dead. Yeah, that stuff happens because it's burning without enough oxygen. And you know this if you know anything about chemistry, and it's not even chemistry, it's science stuff. You'll know this because L21. Because if you look at the molecule of carbon dioxide versus carbon monoxide. L21 right there. Carbon dioxide versus carbon monoxide. If you look at the words, di, 2 oxygen, mon, 1 oxygen. So carbon dioxide, carbon monoxide. It tells you which one it is. It tells you how much oxygen there is. So if it doesn't have enough oxygen, it's going to eat up all the oxygen in the room. And, well, yes, if there's only CO2 in the room, you're going to suffocate anyways. But carbon monoxide, what happens is it has the right molecule size and shape that it likes to bond to our red blood cells, and it does not like to let go. And our red blood cells are how we get our oxygen from our lungs to our to the rest of our body, to all of our muscles. That's how we do it. And if you don't have enough, if all your red blood cells are bound up with carbon monoxide, your blood won't be able to carry the oxygen. It will starve your all of your cells of the food it needs, the oxygen that it needs to digest sugars and make that sugar into fuel. Or use that fuel. Burn that fuel in the cell. And you will suffocate and die. Even though you're breathing, you're just breathing something that... And you can even breathe oxygen after you get enough, like if you get too much carbon monoxide in your lungs, even after you get put on straight oxygen, if there's not enough red blood cells for you to get enough oxygen to your cells, you can actually still die. That's part of the reason why they put you on pure oxygen, because they want nothing going into your lungs but oxygen at that point, because they need to get all that carbon monoxide out of you as soon as possible, because it's actually in your blood. It's not just hanging out in your lungs, it's hanging out in your blood. And so your respiration has to happen a few times to get it out. So, back to free energy. Why do free energy devices not work? Well, we hit upon that a lot, saying that, hey, you need a place for energy to come from and energy to go to. It's a flow of energy. Just like on a electrical circuit. There's a flow of energy. 1, 2, 4, 5, 6, 7, 8, 9, 10. There's a flow of energy, and where that flow happens is from high pressure to low pressure of energy. A good example of it is high and low pressure systems. If you notice, high pressure systems blow towards low pressure systems in nature. Yeah, that's just how nature works. Temperature, the hotter temp, your AC doesn't cool by pushing cool into you. It works by sucking heat. Um, I had a science teacher back in the day that loved to say, "Science doesn't suck; it blows," and it's true. Every all of the most all of the different ways that things move, energy moves, is all from high to low. It never goes, it never pulls. So, all right, let's look here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is a 12 wrapper. All right. The other one that we need to do is 42. 42. L42. Looks like it is right up here. Dropping that in. Wait. Keep on forgetting this. I want to shave these. So yeah, so why can't we use a free energy device with like magnets? I've seen these videos a lot. These magnet perpetual motion devices, free energy devices with magnets. Magnets don't work that way. There will always be more energy used to turn that wheel than there will be used or than what will be made from the magnet. And people say, well, if I get the magnets orientated just right, they'll kind of sneak up beside, and then they'll be presented, and then they'll push or pull. They'll be pulled, and then they'll slip to the side, and then I can have another one pull and slip to the side. That doesn't work. It does not work. The reason being, the energy that it takes to slip it to the side is always going to be equal to the amount of energy used, or the amount of energy that is made by bringing them together. And actually, you're going to use a teeny bit more, because you're at a minimum, you're going to use a teeny bit more because of friction and wind resistance, and you can't overcome it. Now you can minimize it. You can minimize those other forces. All right, now we're working on T8s. You can minimize those forces. That is possible. You can get it into, let's say that you put in low Earth orbit, all right, or even you get it out of Earth's gravitational field, Earth's gravity well, as scientists put it. Let's say that you do get it out of Earth's gravity well, all right? So you don't have gravity working on it. And let's say that you can get it, you use a couple of magnets to suspend it midair. I'm going to take a sip of my water here. Ah, man. Good high quality H2O. Distilled, or not distilled, RO water. But yeah, let's say that you get it suspended between two magnets. And so you minimized your resistance, your rolling resistance. And because you're in space, you have no air resistance, all right? So you got rid of gravity, friction, and air resistance. That's pretty good. That is, you're on the right track there for having something that is as efficient as possible with the energy it has. But again, even in a system like that, and actually technically in space, space is not a 100% vacuum. It isn't. There are particles out in space, very microscopic things floating around in space at high velocity. 2, 3, 4, 5, 6, 7. And those things, every once in a while they'll hit like the International Space Station, or they'll hit something. And, well, you have something hit it, and that imparts a little tiny piece of force, a little tiny amount of force into that system. If it's going the same way that you're wanting it to go, then all right, well, that's a positive for you. But there's no way of tracking every little tiny piece of space dust in space. We can track a lot right now. NASA can track a lot of stuff in space. And it's not even just NASA. There's other space entities that are tracking a lot of space debris. There's a lot of space debris out there, especially in low Earth orbit. 1, 2, 3, 4, 5, 6, 7, 8. We got 8 wraps. But yeah, even in low Earth orbit, there's a lot of space debris out there. Even if you get away from there, there's still a lot of stuff out in space. A lot more than 0. All right, and that's to theoretically have something moving forever. You have to put it in a theoretical mindset of there is absolutely nothing else. And there's always something else. Alright, this T8 that I put together goes into L22. You can see that there. L22, I can see it right up here. And we'll drop that in. And I'm being a little bit nitpicky. If you notice, all my toroids that are this way, they're turning this way. All of them have their black side there and red side there. All of them that are turning this way, red on that side and black on that side. Don't need to do that. I'm just doing that because I'm a little bit nitpicky. I'm trying not to use the term OCD because I don't actually have that disability. Slash ability. There's some things about OCD that is beneficial, but it is a disorder. So, all right, now I'm on to 15 turns. But yeah, so yeah, there's a lot of guys out there that can explain why the magnet stuff won't work a lot better than I can, but just suffices to say having them present and then repel and then present and repel, bringing them together, even if you bring them together sideways and then do that, you're still using energy to do that, equally proportional to what you're going to make. And actually you're always going to use more energy than what you will get back out. Now, my mother, and I don't mean to throw my mother under the bus. Mom, if you're out there listening, I'm sorry I'm bringing this up. But my mother was a little bit ignorant about this. And we sat down and I had to discuss this with her and show her why there's a car brand out there, and I'm just going to name the car brand Tesla, has regenerative braking. Basically, regenerative braking, what that means is you are taking the energy from your movement and you are turning a motor with that. Alright? Or, well, a generator. Alright? By the way, in big three-phase motors, motors and generators, they're the same thing. They're interchangeable. It's just what are you putting in, what are you getting out. If you put in electricity and you get out motion, it's a motor. If you put in locomotion and you get out energy, it is it's a generator. That's the only difference between a motor and a generator in three-phase power, which is what Tesla's using. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, what they're doing is they use the motor to spin the tires on the car and to move the car. Alright? Then you get the car up to speed and you come up to a stop sign and you need to brake. Well, what it does is it takes that motion energy and it converts it from motion back into electrical energy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14. One away. So it takes that motion and it turns it back into electrical energy and it puts that back into the battery. And my mother asked me, well, why can't they take that motor or take that generator, that regenerative braking, and put on another generator, because you're using the motor that's turning the wheels to create the energy. Why can't you take that, put on a second motor and have that create the energy to make the car go while you're accelerating? So basically you spin up the wheel with a motor and then you have that feed into a generator that then creates the power to put it back into the motor. Why does regenerative braking work but you can't do that? And it comes back to the conservation of energy and matter. And really it's the conservation of energy. So the energy is coming from the battery, goes into the wheels and propels the vehicle. Alright, now you have kinetic energy. That's what that's called, kinetic energy. You can convert the kinetic energy back into electrical energy, and you can put it into potential energy in the battery. We can do all that. But you cannot take more energy than what is put into the system. Alright, so we have this 15 turn and we're going to L31. So let me look on here. L31 looks like it's right there, and I am looking at the red side. So L31 right there, and we give it a quick twist. Alright, got that one done. Let's go down here to 17 turn. Doing a little bit of a stretch. So, you put energy, you take energy from the battery, you put it into kinetic, you take energy from the kinetic, and you put it back into the battery. It's like you're making a cake. You're making a whatever you want. All right, you put in your recipe here. If you have a good recipe, put it in the comments. Love to try it. I might even do a cooking one of these. So you're cooking and you decide, all right, I need 5 cups of milk. So you take 5 cups of milk out of your big milk jug and you put it into your container, into your bowl. All right. Now, your bowl is the movement of the vehicle, all right? And you're using some of that energy in that bowl, all right? You are, you may go uphill, which uses some energy. Your tires have friction, which uses some of that energy, uses some of that milk. So your tires to the ground, your axles are not zero resistance, are not zero resistance rolling. Now, mind you, bearings, they're a lot better than the old packing hot boxes, or the packing boxes that they used to have on the railroad, but roller bearings are a lot better than that, but there is still some friction there. There's a lot of things. Wind resistance. We've talked about a lot of these reasons why you slow down, why energy gets dissipated. Alright, so you put in some flour, alright? The flour doesn't absorb all of the milk. There's still some milk in the bowl. Well, any milk that doesn't get absorbed, you can, this is a bad analogy, but you can scoop that milk out of this bowl and you can put it back into the refrigerator in your milk carton. I gotta come up with a better example of that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14. Alright. Gotta get 3 more to get my 17 wraps. So yeah, you can move where that energy is, but you can never take more out of the bowl than what you put in. Let's say that you go out into space, you have this theoretical perfect scenario where there's no resistance at all. Alright, you have 0 gravity, you have no particles in space, no air friction, like no air resistance, no wind resistance, no insert your resistance here. Alright, you have 0 of it. Even in that system, you can't take more milk out of the bowl than what you put in. You haven't used any flour. You can't take, if you put in 4 cups of milk, you can't take 5 cups of flour out, or of milk out, because you didn't put in any flour. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15. Did I do that wrong? Oh, I was going to 17. Let's count again. 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Perfect. So yeah, you can't take out more than what you put in to any system like that. And if you can, well, you can't even get a patent for it because the U.S. Patent Office does not accept patents that say that they do that, because they know, the U.S. Patent Office knows it is impossible. And I'm sure I'm going to get some flat earthers. By the way, I'm not a flat earther here. But I know I'm going to get some fat earther trolls in the comments. That's okay. You can be wrong. We all still love you. I'm not going to shun you because you don't agree with what I say. By the way, that's one thing that I wish more people would live by here in the States. Just because you and I have a disagreement does not mean that you and I can't have an intelligent conversation about it. And that's where I draw the line. An intelligent conversation. I don't want unintelligent conversations. So this T17 is a 41. 41 is right here on the board. I have already stripped it, so we are going to just throw that in there. Do I have it the right direction? Again, the direction really doesn't matter. This is just me being picky. Man, I want to use that term. The OCD term. I'm not OCD. And I'm not saying I'm not OCD because, well, I'm better than, no, I'm not going there. No, I'm not better than them. Sometimes there are some things about OCD-ness I wish I could have. But I know that I do not want OCD. It is a thing that you would have to live with, and there would be there's a lot of problems that come with being OCD. It is a disorder, by the way. And again, I'm not coming down on OCD people. I'm not saying that they are bad. I'm saying for it to be a disorder, again, OCD, over compulsive disorder, or obsessive compulsive disorder, it is a disorder. Disorder means that it is adversely affecting you in your daily life. Talk to any therapist. That's what they say. A disorder adversely affects you in your daily life. If it's not adversely affecting you, it's not a disorder. You may be obsessive compulsive, but if it's not affecting your daily life in a bad way, it's not a disorder. Alright, sorry, I just unwrapped these. He did give me the through-hole ones. If you watch the video on DL2MAN, his website, he shows how you can take the surface mount and you can straighten those pins and you get a through-hole. Well, these are through-hole to begin with. Alright, we got two more toroids to wrap. So the next one is 19, and then we got another 15. So, but we're not going to be done wrapping by then. We got three of these, which are going to be transformers. I don't, yes. So a couple of them are noted here. There's a 1 to 7 and 3 to 21, and there should be a third. There is K5, K3. Nope, no, those are, sorry, those are the relays. Let's see here, T1, T2, and is that it? I guess there is just T1 and T2. All right, so right here, T1 and T2. They're on the boards. We're not to this quite yet, but I'm going to point this out. T1 is this 1 to 7. There is a update out on dl2man.de on his website, that website right there. There is a fix, and they take this 1 to 7 and they go 3 to 21. So we will be doing that fix. They show, there's on the website, they show a heat map of this, and there's a lot of heat in this transformer right here. And to dissipate that heat, because again, heat is loss in this circuit. So we don't want heat, and that all that heat is just taking our energy that we're putting in here and heating up the atmosphere with that. So we don't want that. So yeah, like I said, I wish that we could, back to what I was saying, I wish that we had more people that could talk about things intelligently without being mean and nasty to each other. I try and talk to people the way I want to be talked to. I try and be nice, and like I said, I try and live by that golden rule. Do unto others as you would have them do unto you. And even when I'm talking politics, I would rather walk away from a conversation that you and I may not come to an understanding in this sitting. We may be on opposite sides of the spectrum. But I do love having a nice, again, intelligent conversation about my beliefs and about your beliefs. And if we can come to an understanding, great. If we come to an understanding of, well, we agree to disagree, that's okay. I'm not opposed to that. That means that you and I just haven't found that common ground yet. And once we can find that common ground, hopefully we can talk to each other like human beings in between. I'm going to turn that up. You guys better view. I'm sorry if I've been pulling things off of camera. But yeah, my father and I get into some heated conversations. Heated, not fights. that is a difference in my book. Alright, we are working on this 19. Alright, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, we have heated conversations, but not fights, about politics and belief systems. We are both of the same faith. I'm not going to go into what faith I am again. I'm not trying to start fights here in the comments. But we are of the same faith, but we view the faith in different ways. We both do our best to adhere to the faith. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17. But we don't see eye to eye. He has joined a men's group that is a faith-based men's group, and there are some things that group says and believes that I do not adhere to. We've been here for an hour and 15 minutes. Wow. Hour and 18 minutes, sorry. Or is that 16? Gotta look at the camera here. Hour 16 minutes. So we're gonna wrap this one up pretty quick here. But yeah, he has joined that men's group. That men's group says and does certain things that I do not agree with, but they do it in the name of that faith. Now don't get me wrong, it's not like some radical, they're going to go out and do anything. They're not that way. They just say, if you're going to be a part of our group, you have to believe these certain things in this faith. And I don't believe those things. So he has asked me to join numerous times. I respectfully say, I can't in good conscience go to those meetings because you have to believe certain things according to that group, and I don't believe those things. So I'm sorry, but I'm not really sorry about it. It's just I'm more sorry about that we can't go to things together like that. Alright, we are doing L51. Why am I coming up with extras that I need? L15 doesn't have one. L51 doesn't. L52 doesn't. 52 is the next one I'm doing. Where did I miss L15? I don't see L15. Oh, L15 is all the way down here. Okay, so we've got one more to do. Man, this is going to be a long video. Did I already strip this? I forget. But yeah, I love my father. I don't hold any of that against him. It's just, we just don't see eye to eye, and that is okay. That is not, it's not a deal breaker for him. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 19. Perfect. 19, that goes to L51. L51. Do we have it? Yes, we have it going the right direction. Now we go on to L52. It's a 15 turner. And all of these have been using the T37, which are these, but see that the L15, this may not be on the camera, the L15 over here uses an FT37, which I believe is one of these. So that's why it's different. Okay, that's why it's down below. So we're doing a 15 turn. We've still got a little bit of our slinky here. So yeah, what we're going to do is, in this video, we're going to just get all of these toroids wrapped. And then once we get them all wrapped and on here, we will solder them. Got my soldering iron here. Once we get them all soldered, I'm going to end this video. This thing's going to be a long video, hour-and-a-half video. Me just rambling. So, by the time I get any subscribers to watch this, this project is probably already going to be done. If you guys have any questions about ham radio stuff, you guys want any advice, hit me up in the comments. I'll either add the comments and answer some questions. I'll answer the questions in the comments. Right now, because I have like 0 subscribers, I will answer every subscriber or every comment. I'm not going to promise that I'll always do that, because then you get into a problem like some of these big time YouTubers get into, where there's just bombarded with 50,000 comments a day, and there's no way I can even try to keep up with that. So, but right now, with the numbers as they are, where I get like a subscription a lifetime, yes, I will answer every, or I get a comment a lifetime. I will answer every comment. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Hey, that's where I stop. Because again, 15 turns for L52. So yeah, I'm not trying to badmouth either of my parents. Both of you, if you're out there, I'm sorry if I've offended you or if I've said something that I shouldn't have. But I feel like I've been fairly respectful. I try and honor my father and mother. That may have given away my faith. Let's put it that way. I don't fall into religion. I don't follow man. I follow God. I follow the higher power. I do not believe that a priest or rabbi or whatever should be the end-all be-all of the faith, of how you are supposed to believe, because even people that started off with good intentions, the road to hell is paved in good intentions. Let's put it that way. So I don't just blindly believe what I am told. I will ask questions of my faith. I'm not going to tempt my God and say, God, if you are real, do this for me. I'm not going there. I'm not doing that. But I will, that's probably a good stopping point, so we'll go ahead and solder these in then. I will question my faith. I will question, why do I believe what I have been told my entire life? I will look on, I will look at the Bible and I will read it with a grain of salt. I will take my belief and go, you know, I have always been told that I need to believe XYZ because of ABC. And I'll go, you know, the Bible was divinely inspired. That's what they say. And I think I believe that. But it may be divinely inspired, but has it been altered? And actually, I believe that the Bible has been altered over the years. And anybody that says not, sorry, but there's actually a lot of really good evidence that it has. The Bible absolutely has been altered over the years. Now, were those alterings divinely inspired? That's the question. That's the rub right there. Was it actually divinely inspired? If it was, then great. God has added meaning, has helped us to know His meaning by having people interpret His meaning and alter the Bible. The ways that the Bible has been altered. All right, this is going to get into some sticky stuff here. All right, there are books of the Bible that have been removed from the Bible. All right, so those alterings, that is altering it. The Catholic Church back in the day said, well, these books should not be a part of the Bible anymore. I think it was the Catholic faith that did that. Don't quote me on it. But there was a group that said, these things should not be a part of the Bible anymore. And so they aren't anymore. But now the question is, like I said, was that divinely inspired? Was that what God's will was? If it was, great. If it wasn't, we should probably start reading into what those books said. Likewise, from time to time, the Bible gets updated. And updated, there's different dialects of the Bible. And you see this all the time. There's the King James Bible, the NIV Bible. There's half a dozen of them. They are translations. That's the word I was looking for. It's been translated a lot. Well, who's doing that translation? Is God doing that translation? Or is a human doing that translation? Well, it's a human. God never wrote the Bible. God inspired the Bible. So, if God inspired the Bible and humans have translated it, is it possible that somebody down the line translated it incorrectly? I think it's highly probable. I think it's actually more probable than what a lot of people think. Because if you read the Bible in multiple translations, this is something that a lot of people don't do. They read it in the translation that they were brought up in. For instance, somebody that their church, their parents, they had a King James Bible, and that was the Bible, end all be all. Alright? And then they grow up and there's this NIV Bible, or there's this other rendition of it, translation, I should say, of it. Well, what do you believe? Do you just blindly believe the King James Bible at that point? Or do you say, hey, this is a translation of the Bible. Let's try and look at where the translation came from, how it was translated, and how did this other one that contradicts, yes, the Bible contradicts itself depending upon which version you read. So, if you go, hey, yes, it is contradictory, and you read into, all right, why is it contradictory? And you find out why, and you go, well, that makes sense on why that somebody screwed up. Then you need to go, all right, I'm going to read where the two forms may have went apart, or if one is a derivative of the other, you may choose to look at where both of them were translated from. So let's say that Bible A was written and then Bible B was translated from Bible A. Alright? Well, you may want to look at the Latin or Hebrew or wherever it came from, that book came from. Look at that what that translation was, or the original. By the way, I don't know that we have the originals. I think all we have are translations. Documented pretty high up translations, but translations nonetheless. So if you look at where those translations came from, you may be able to say, oh, well, here's where I think, and this is your walk with God comes into play. what the Lord is leading me to believe is the current truth, or is the truth. And because of my relationship with the Lord, I believe XYZ. Not because somebody tells me to, not because the Bible that I grew up with says that this is the way that it should be translated, but because I'm going off of my faith in the Lord and my walk with God, my experience with God, my conversations with the Lord. Alright, it's ugly. I'm going to get some better nippers, and I'm going to nip all those. So yeah, that's where we're at. Let's flip it over. Looking okay. I've got some work to do. I'm in a badly lit room here, and I know a bad worksman blames his tools. I'm blaming my tools, aren't I? I don't know that this video is going to get posted, just because of the length of it, and I don't know that I've never really put my theories about God and stuff out there. Not because I'm ashamed of it or anything. It's just I know that there's a lot of people that disagree with what I say, what I've said. And again, I'm not looking for drama. But maybe I should post it, because maybe that's what the Lord is leading me to do, is to post it, to hopefully inspire somebody to question their religion, not their faith, their religion. Question your religion, not your faith. Well, question your faith, but